Hello, everyone, and welcome. My name is Eric Franzen, president of SemanticWeb.com. We would like to thank you for joining us today for this webinar, a joint production between Dataversity and SemanticWeb.com, with our speaker, David Booth. Today, David will be discussing the Yosemite Project, an RDF roadmap for healthcare information interoperability. Just a couple of points to get us started today. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them during the session in the Q&A section of your screen. It's in the bottom right-hand corner. If you'd like to tweet, we encourage you to share highlights, and you can also ask questions there. Just be sure to use the hashtag SemanticWeb, all one word. As always, we will send a follow-up email within 2 business days to all registrants containing links to the slides, the recording of this session, and additional information requested throughout the webinar. With that, please allow me to introduce you to our speaker for today, David Booth. David is an independent contractor and a senior software architect at Hawaii Resource Group, using semantic web technology to make clinical healthcare data interoperable between diverse systems. He previously worked at NoMed, using semantic web technology for healthcare quality of care and clinical outcomes measurement, and at PanGenX, applying semantic web technology to genomics in support of personalized medicine. Before that, he worked on Cleveland Clinic's SemanticDB project, which uses RDF and other semantic technologies to perform cardiovascular research. And prior to that, he was a software architect at HP Software, where his primary focus was emerging technologies. He was a W3C fellow from 2002 to 2005, where he worked on web services standards before becoming involved in semantic web technology. He's been programming for many years using a variety of programming languages and operating systems, and he holds a PhD in computer science from UCLA, and every time I listen to him, I learn something. So we are in for a treat today. Sit back, enjoy, and please help me welcome David Booth. David.
Thanks, Eric, and thanks for inviting me to present here. So first of all, I want to give just a little background on where this came from. At the 2013 Semantic Technology and Business Conference in San Francisco, we ran a workshop on exploring the possible use of RDF as a universal healthcare exchange language. The workshop went very well, and the culmination of that workshop was a proclamation that we put out that we called the Yosemite Manifesto, that basically stated that we believe that RDF is the best available candidate for a universal healthcare exchange language. And it outlined a few principles about that. You can look up Yosemite Manifesto on the web if you want, or just go to YosemiteManifesto.org if you want to see what that was. And about 100 people signed that who were knowledgeable in healthcare and knowledgeable about semantic web technology. So the Yosemite Project, then, is a follow-up to that actually lays out a roadmap for how we can achieve this, how we can achieve the interoperability of healthcare information using RDF. So the outline for today's talk, I'm going to just go over the mission and strategy first. Then I'll talk a little bit about semantic interoperability in general, and specifically 2 ways of approaching it, one a standards approach and the other a translations-based approach. Then we're going to go through the roadmap itself for interoperability. And finally, we'll talk just briefly about cost. So the mission of the Yosemite Project is to achieve semantic interoperability of all structured healthcare information. That's a tall order. I want to pull out one word here. I want to focus on the word structured. So this is focusing on structured healthcare data. It is not trying to address things like doctors' prose notes that really a human has to interpret to properly interpret. So this is talking about the structured healthcare information and achieving interoperability of it. So this may seem like an impossible task, but I think it actually is possible. And that is the purpose of describing this roadmap, to say how. So the basic strategy here it relies on the use of RDF as a universal information representation. That is the foundation of this strategy. So what do I mean by that? Well, the best way to describe what I mean is if you have some instance data, like instance data such as that shown on the left here of the screen, and you want to ask, well, what does that instance data mean? What is the meaning of that instance data? Then the answer would be to determine its RDF information content and say that RDF information content that corresponds to that instance data is what that instance data means. So in other words, if we use RDF as a universal information representation, it would enable us to have a common way of interpreting instance data in terms of RDF. Okay. Now, there are a number of reasons why RDF...
David,
yes.
Sorry to interrupt. For those
Sure.
who are texting me notes about the visibility of the slides, you can adjust the view of the slides using the tools at the top right of the slide window. You can resize those so that you can see them appropriately on whatever device you are on.
And feel free also to download the slides if you want to go to dbooth.org/2014/Yosemite. You can just download the slides and you could look at them asynchronously as well. That would be easier for you. So we're on slide 7. So there are a number of reasons why I and a number of other people believe that RDF is the best available candidate for this kind of purpose. And I don't have time in this talk to get into the details of why. There's another presentation that does go over that, and you can download the slides and read through that from this link here. A few of the reasons, though, are, one, that RDF focuses on the information content, the meaning of what that information is supposed to convey, not just on syntax. In fact, there are different RDF syntaxes available, and as long as the information is captured in some syntax, it doesn't really matter what the syntax is, as long as it can be interpreted as RDF information content. Another reason is that it allows data models and vocabularies to easily evolve. In other words, it's very good for accommodating changes to data models and vocabularies. It's what we call multi-schema friendly, which means that RDF doesn't try to impose a single schema on your data. Rather, you can use multiple schemas and they can work together. They can be interconnected, and relationships between those schemas can be expressed also in RDF. It turns out RDF is pretty good for model transformations as well, and I'll get into a little bit more about that. So there are a number of reasons why RDF seems to us at least to be the best available candidate for this kind of purpose, and you can look at that separately. What we're trying to achieve here is semantic interoperability between systems, and I like this definition from Wikipedia. There are lots of other definitions that you could use, but this is a pretty simple one, but I think it gets to the point. It's the ability of computer systems, we're not talking about humans here, we're talking about computer systems, to exchange data with unambiguous shared meaning. That is really the objective. That's what we want to achieve. How can we do that? Well, fundamentally, there are two basic ways we can achieve that. And these two approaches I'm going to call a standards-based approach and a translations-based approach. In the standards kind of approach, you basically make everyone speak the same language, and that's how they can interoperate. And in terms of computers at the data level, what this means is that you make them use the same data models and vocabularies so that those computers will understand each other. So that's one basic approach. But if for some reason everybody doesn't speak the same language, in other words, if you've got different computer systems speaking different languages, then the only other option is to translate between languages. And at the computer level, at the bits and bytes level, what that means is translating between data models and vocabularies. So those are the two basic ways of achieving interoperability. There are no other choices. You can take one or the other or both. Okay? Now, obviously, the standards-based approach is the better approach. And it's the better approach because it involves a lot less work. You don't have to do all that translating. But there are some fundamental problems with it, with a standards-based approach. One is that standardization can take time. And in fact, the more comprehensive you try to make a standard, the longer it takes. So if you tried to do a comprehensive standard that covered all of healthcare, you'd never finish. So it's kind of like if you've worked in software, there's this software trilemma where you can pick any two, but you can never have all three. Well, it's similar here with standards. You can have any two of these characteristics, but you cannot achieve all three at once. You can either come out with a standard quickly, or you can come out with a high-quality standard, or you can come out with a comprehensive standard, but you cannot achieve all three of those objectives at once. Just not possible. Okay, so another fundamental reason, or another fundamental limitation of the standardization strategy is that modernization takes time. So even if you do come up with a great new standard which you think that everybody should use, it's going to take them time, right? You cannot upgrade all of the healthcare IT systems all at once. It would be years before they would all get upgraded. Another fundamental reason on slide 14 is that there are different use cases that make use of the data. And they have different requirements. They might need different kinds of data. They might need different granularities of data. And they might need different data representations, different ways of representing that in different kinds of data models. So in this little example, I've shown two ways of representing blood pressure. And in the way on the left, you can see that the systolic and diastolic are written as a single string as 120/70. And in the data model on the right, they are broken apart into two separate numbers. Okay. Furthermore, in the one on the right, there is additional granularity. There's additional information there that includes the body position. It says how the patient was positioned when that blood pressure was measured. Now, not every application or use case would care about the body position, but some of them would care a lot. Okay, so the point is that not only do different use cases require different kinds of data, they may require different granularity and different ways of representing that data. So you cannot just have one standard that is going to make everybody happy in using it. Okay, another fundamental issue is that standards don't stand still. They evolve. In fact, the only standards, as Doug Frisma likes to say, the only standards that don't change are the ones that nobody uses. They're the ones that are dead. Okay, so somehow we have to accommodate the fact that standards are continually evolving. And Dr. Raphael Richards at the VA actually looked up some of the stats on various common healthcare terminologies to see how rapidly they do change year over year. And on average, they were typically changing between about 3 and 8% per year. So somehow those changes have to be accommodated. So the moral of that story is that as much as we would like to use a standardization strategy, and as much as standardization is always preferable when you can do it, the fact is that translation is unavoidable for these fundamental reasons. We simply can't get around it. Okay, therefore, any realistic strategy for semantic interoperability must address both standards and translations. And the hope is that over time, of course, the bulk of the interoperability that's achieved will be achieved more and more through the use of standards as standards converge and we are able to use a consistent set of standards. But the amount of translations will never go to zero for those fundamental reasons that I just described. Okay, so now let me dig in a little bit to discuss how RDF helps standards. So I'm going to talk now about a two-pronged strategy, a standard strategy and a translation strategy. And first about the standard strategy. So if you look at the Unified Medical Language System, they catalog over 100 vocabularies, standard vocabularies that are used in healthcare. That's a lot. And I love this cartoon by XKCD that describes how standards tend to proliferate, what causes them to proliferate. I'll just give you a moment to read that. It starts off with 14 competing standards. And they boldly go off to develop one universal standard that's going to cover everybody's use cases, and pretty soon there are 15 competing standards. Well, kind of sad, but true. The fact is that when we have all of these standards, even though we've got a lot of standards, they tend to act as islands. And each one kind of has its own sweet spot of use. And typically they're developed by different committees with different domains of expertise for different purposes. But there's also a lot of duplication between them. So what we'd really like to do is we'd really like to bridge these different standards to allow them to kind of work together, not as islands, but as a cohesive mesh of standards that give the effect of acting as a single comprehensive standard. Now, we don't want to try to boil the ocean and, create a committee that's going to set out to develop a single comprehensive standard of all of healthcare. That would never complete. That would be hopeless. The idea here is to enable these existing standards and any new standards to be interlinked using RDF and OWL to express the relationships between the various concepts in all of these different standards. Okay, now to facilitate that, one thing that I think would help quite a bit would be what I'm calling a collaborative standards hub. You can think of this as being a sort of a cross between the existing BioPortal hub. BioPortal, if you haven't heard of it, it's a website supported by the NCBO, the National Cancer Biological, I forget what it stands for. It's under the NIH, though. And it catalogs a lot of ontologies in a lot of biomedical ontologies. So think of this as a cross between BioPortal, GitHub, which is a very commonly used open source collaboration site, Wikidata, Web Protege, if you've heard of it, SIMI repository, HL7 Model Forge. Think of it kind of a combination of these. And maybe it would even be the next generation of BioPortal. Could even be that. The point is that this would be a hub where various different standards could be defined in RDF and OWL, and then relationships between them could be expressed. So let me get into this a little bit. So it would be a repository for healthcare information standards defined using RDF and OWL definitions. It would be, the purpose would be to support both the standards groups that need to maintain these standards and help them to express them in RDF and OWL representations, and for use by those people who are implementing these standards. And the purpose of putting them into this collaborative standards hub would be to encourage linkage between them and eventually encourage standards convergence, so that instead of having a lot of different standards that have a bunch of overlap that is inconsistent, that eventually we can converge on using a consistent set of terms and data models and things like that. So one of the things that this hub might do, for example, is suggest related concepts if a standards group is putting a concept in there, and to encourage the use of the expression of relationships between concepts related to other standards. So for example, if there's a notion of blood pressure appearing in one standard and also appearing in another standard, then hopefully those could be related through RDF and OWL expressions. It could also check and notify of inconsistencies, both within a particular standard and also across standards. And I think it's important for this hub to provide a browser-based interface that non-RDF and non-OWL heads can use. In other words, that can be used just by medical doctors and those who are defining these standards. But also, I think it's important that this hub provides an API, such as just a simple RESTful API, so that nobody is forced to use this interface. They can use their own favorite interface if they wish. So again, the purpose of this is to hold RDF and OWL definitions of these standards. Now, for a number of reasons, some committees might not want to store their standards in here, and that's fine also. So I think it would be a good idea for this hub to also be able to scrape or reference definitions that are held elsewhere. And for usability, it would be great if the hub would provide metrics, both subjective and objective metrics, such as indicating the size of the standard definition, the number of views of it, the degree of linkage, for example, to other standards. That would be a fairly important measure. And then very subjective information, too, the ratings of who likes it and things like that. So the idea is that it would use RDF and OWL under the hood. It would provide the formalisms under the hood, but users of it should not need to know RDF or OWL. They should just be able to be domain experts, in their own field. So one step in this direction is a tool called ICAT, produced by Mark Muson's group at Stanford, which is basically a customized front end for Web Protege. And this was used to develop the next version of the ICD codes, ICD-11. ICD is the International Codes for Disease, I think it is. And it's done by the World Health Organization. So this was used by over 100, I think close to a couple hundred domain experts around the world to collaboratively and in a distributed kind of way develop the next version of the ICD-11 vocabulary. Now, these users were not expected to be RDF or OWL heads. They were doctors. They were knowledgeable in their field. But underneath here, under the hood, this is actually using RDF and OWL to represent the relationships between various concepts in this vocabulary. So this is a step in that direction. Okay, so that's a little bit about standards. Let me go forward now and talk about the translations strategy and how RDF helps with translations. Because remember I said that you've got to address both components, both standards and translations, to be an effective interoperability strategy. So RDF helps translations in a few ways, but one of the fundamental ways is that it's good at supporting inference. And if you think about what inference means, it means you've got some information, and then from that given information, you infer or you come up with or derive some new information. And that's basically what translation is also. So you can think of the same kind of mechanisms as being good for translation, right? In translation, you are given some information, and then you derive some new information, and it happens to look different than the original information, and that's fine. But it's the same basic kinds of mechanisms, so that's one of the reasons. Another is that, as I mentioned earlier, that RDF can act as a universal information representation. And this is a really important thing because it enables data model and vocabulary translations to be shared. I'm going to get into that in just a moment. But first of all, I want to show you about or explain how RDF can be used as a universal information representation in translating some patient data. So here's the basic process. So we have source language and a target language. And in this case, I've just shown something like HL7 version 2.5. Maybe it's coming from a particular hospital, say, and so it's their particular use of it or version of it. And then on the right is this emerging new healthcare information standard called FHIR, F-H-I-R. that's what the target needs. So some healthcare data, some patient data needs to be translated from that source representation into that target representation. So the basic steps are, first of all, to what we call lift to RDF, which means a pretty direct translation from the syntax, the original syntax, whatever that is, into an RDF representation that looks very much like the original, except that the syntax is RDF instead of the source language. Okay? It's the exact same data model, the exact same vocabularies, but it's just represented in RDF instead of being represented in that source syntax. That's the first step. Second step, I'll get to in a moment. The third step is kind of the complement of that first step. It's the drop step where you go from RDF into the target syntax. And again, that's just a very direct sort of translation, very direct correspondence from the RDF representation of the information into the syntax that's required. So the real hard part is what's happening in step 2. This is this translation step, which is an RDF to RDF translation that translates between the data models and vocabularies that happen to have been used on the left in the source and the data models and vocabularies that are being used on the right by the target. And this is known as semantic alignment or model alignment. So let's dig into that. How can that be done? Well, first of all, I want to acknowledge that it's not easy. It's hard doing this. There are a lot of different data models and vocabularies, but it is currently being done. It is done in healthcare routinely. It's typically done in proprietary black box integration engines. They do this kind of thing. So what are the strategies for doing it? Well, two kind of basic strategies are a hub and spoke strategy or a point-to-point strategy. And what I mean here is for the point-to-point strategy, what I mean is you just do an individual translation from every source language to every target language. Okay, just a special purpose translation for each combination of source and target. So this is kind of an n squared, leads to an n squared number of translations needed. The other strategy is kind of a hub and spoke strategy where you use a common data model in the middle, this common data model and vocabulary in the middle, and you have all of them go to and from that common data model. So this one is a lot better in some senses in that it requires a lot fewer translations. It requires on the order of n translations instead of on the order of n squared translations. But it does require that common data model. Now, one very important observation here is that both of these strategies can be used in this way of doing things, in using RDF and taking this strategy. Both of them can be used. But what that means is if you have a common data model available, then yes, you can use it. Or if you have a point-to-point translation available, then yes, you can use it. In fact, you can even kind of mix and match them. So in a lot of ways, the hub and spoke model is more attractive because it doesn't involve nearly as many translations. But it does require the use of a common data model. And one difficulty of that is that that's a moving target. That common data model that they all have to go to and from has to be able to represent, but not require, the finest granularity that is needed by any of the use cases. Okay, so that's kind of a tall order, and that makes it cumbersome for use in a lot of the use cases that don't care about all that granularity. All right. Now, but another way you can think about this is that even if you do have a common data model like that that has very fine granularity, that does not necessarily mean that the individual use cases have to directly use that data model. Instead, they can map to and from that common data model. Okay, so that's basically how that can be done. It's important to observe that the problem of coming up with that common data model is a standardization problem. So it's the standardization strategy and standardization track that would have to address that. Okay, now, one thing that I did not address yet is where do these translation rules come from? Well, first of all, by allowing RDF to be used as a common information representation in step 2 there in the middle, that allows these translation rules that will do this translation to be mixed and matched and shared. And that's a really important thing because I think that gives rise to a very important potential for a crowdsourced translations rules hub. So again, this is a hub. This would be a hub that would be based on maybe GitHub or Wikidata or BioPortal or WebProtege or something else like that, maybe a combination of them. Its purpose would be to host translation rules. And it would be agnostic about the rules language. It wouldn't care. You might be using Jenna rules. You might be using OWL2. You might be using N3 rules. Maybe you'd use some Sparkle rules or Spin inferencing notation. Or maybe you would even do these rules using Python or Java. I'm actually using the word rules in a pretty loose sense here. I'm not restricting it just to what you would normally think of as a rules language, but really just any executable language that is able to translate from RDF to RDF. Or in the case of, if I back up here just a moment, in the case of steps 1 and 3, doing that syntactic translation to and from the source and target formats and RDF. So when I say rules language, I don't necessarily mean what you would classically think of as a rules language, but just anything that is any kind of language that is executable and can do these translations. So here's some of the metadata that I would envision would be held with these rules that are in this crowdsourced repository. First of all, each rule would have to say what its source and target language or class is. In other words, what does it translate to and from? And one of the things about RDF is that the granularity of expressing what it can translate to and from can be arbitrary. You could have a rule that would translate from one term to one term, or from one entire vocabulary to another entire vocabulary. Or it could translate from one entire data model to another entire data model. Or it could translate from one piece of a data model to another piece of a data model. There's a lot of flexibility in RDF to be able to do that. So the metadata would also have to include the rules language. What language is this rule written in? It would have to indicate any dependencies. It would be good to have it include some test data or validation information, license information, unless it's forced to be, say, an open source license by policy. Who's maintaining it. And again, it would be good for it to provide some usage metrics and ratings, both objective and subjective. How many people downloaded it, who the author is, et cetera. Who likes it, how many people like it, what are the reviews on it, that sort of thing. Okay, let me also stress that in using this crowdsourced translation rules hub, no patient data is going to be sent to that hub. This is just a hub for the rules themselves, the rule definitions themselves. So the patient data is still held where it is normally held, and the rules are executed then privately by the healthcare institutions that are actually doing this exchange. So you're not sending patient data up to the translations hub. Okay, so I've talked a little bit about how RDF supports both the standards approach and the translations approach. Now let me get into the roadmap itself for interoperability. The basis of the roadmap starts off with RDF as a universal information representation. That is, again, the foundation, the use of RDF as a universal information representation. And that gives a common semantic basis for looking at any kind of information, because any kind of data, of structured data, can be translated to RDF or mapped to RDF, can be in some sense viewed as though it is RDF as long as you have a defined mapping into RDF. The second step, let me just mention here on the roadmap as a whole that you see we've got two tracks here, a standards track and a translations track. Okay, and both of them, as I said, are needed. So the second step on this roadmap is that for common healthcare information representations, we need to define an RDF mapping to and from each format or data model and vocabulary. In other words, these are the lift and drop steps that I just mentioned on that previous diagram. And when I say common healthcare information representations, I mean both standards and also proprietary representations, because there are still a lot of proprietary representations as well that are common. So both are needed. So this will get the information into RDF, or allow it to be viewed as RDF, or allow it to be interpreted as RDF, I should say. So slide 44, the next step 3 on the roadmap is defining translation rules for the instance data that is expressed using those RDF representations. So these rules then would translate between the various data models and vocabularies that are used in those RDF representations of common healthcare information representations. Okay, next one, 4, is to create a hub for crowdsourcing those translation rules, as I described. That crowdsourced translation rules hub can allow those rules to be shared and improved upon. So step 5 in this roadmap on the standards track then is to create RDF and OWL definitions of the data models and vocabularies that are defined by these various healthcare standards. Actually, I said standards on this slide, but really what I mean is healthcare information representations, whether they are standards or proprietary, doesn't matter. The need is to define RDF, to create RDF and OWL definitions of them. Number 6 on the roadmap is to create this collaborative standards hub, as I described, for placing those RDF and OWL standards definitions in order to facilitate standards convergence, right? By having those standards expressed in RDF and OWL in that common place, or at least having a copy of them in that common place, then the relationships between them can be captured also in RDF and OWL, and it can be used to facilitate the convergence of these standards. And again, when I say the convergence of these standards, I mean eliminating the overlaps and conflicts between all of these, over 100 different standards, right? So that they can eventually converge on using consistent definitions of concepts and consistent data models that are cleanly interrelated. Step 7 is to adopt policy incentives for healthcare providers to achieve semantic interoperability. This is, I think, necessary, at least in our world of healthcare in the U.S., because healthcare is run as a business in the U.S., and the fact is that there is no inherent business incentive for a healthcare provider to make its data interoperable with anybody else's data. There just is no inherent business incentive to do that. Therefore, to create that incentive, policies are needed. Both carrot and stick policies are needed to force that interoperability to be achieved. I don't see any way around that. Oh yeah, so here's my note about no natural business incentive. Okay, so that's the roadmap. That's all 7 steps of the roadmap towards semantic interoperability. So the next logical question is, okay, so given that that is actually possible, how much would it cost? Well, here are my wild-ass guesses. When I initially wrote up these guesses, I wrote for standards as an initial cost, I wrote 40 to 50 million. And for translations, for initial cost, I wrote 30 to 40 million. And etc. Well, I was talking to Doug Frisma at the ONC about this, and he looked at that and said, you got to add another 0 to that. So I added another 0 to it. So the point is not that these are necessarily exact estimates. Obviously, they're not. They're just my guesses. But the point is that, yes, it will cost something, but it's time to look at what it will cost, and it's time to actually figure out what it will cost. And it's time to compare it with the cost of not achieving this interoperability. And here is just one figure of the net cost of the lack of interoperability of $30 billion per year. That's $30,000 million per year as the cost of the lack of interoperability. Compare that mountain of cost with the molehill here of what it would actually cost to achieve interoperability, and it's a vast difference. This would be, in my view, there would be a huge payoff in actually going ahead with this and doing this kind of interoperability. But, you know, overall, most of all, I think it's time for us to actually look at this and look seriously at it and say, yes, we can do it. What will it cost? And let's do it. So that brings me to the end here. I'd like to open the floor for questions.
All right, David, thank you very much. We do have a few questions. My apologies if you feel you've answered some of these already, but I do want to let people get these questions in, and perhaps some repetition might be useful here. It's a lot of heady stuff. First question, as users, do we have an option to choose between standard and translation-based approach? Because of the compliance regulations, security, skill sets, I believe we are forced to go with standards, even though it may take time to settle, at least stay with the crowd. So I think that last piece is more about majority rules as far as what's gaining popularity.
Yeah, so my comment would be that the standards approach is generally preferable. And it's really not usually a matter of choice. It's usually a matter of, if you've got no other way to do it, then you translate. In other words, if you do not have suitable standards that meet the needs, then you're forced to translate. So it's not really a matter so much of preference as necessity.
Okay. So then, following on with that comment about standards, the next question is, there are so many standards provided by NLM. Can we use all? Are there any license procedures to be aware of?
So, unfortunately, there are license issues to be aware of. Some of them are proprietary, so that is one of the barriers. There is more of a trend, I believe, now toward more open licensing, and the newest HL7 standard called FHIR, F-H-I-R, actually will be an open license. But yes, there are license issues. Can we use them all? Well, they don't all necessarily work well together. They don't all play well together at present. In general, each one was developed for, you know, it's a particular kind of use case or a particular domain, and they don't all fit together properly right now, and that is part of what this strategy is intended to address.
Okay, let's see. Does it make the translation easier if the source models already have RDF semantic markup?
It might make it easier, but you still have to do that middle step, what I called step 2, which is semantic alignment. And that is generally the hardest part of the step, because it may be easier depending on what the target model is. If the target model is already fairly semantically aligned with the source model, then it is easier. But it all depends on what the target model is.
And has the common data model been developed as yet?
No, it hasn't. That's kind of a holy grail, I suppose. And that is more of a theoretical concept that I put out there for illustrative purposes than an actual real thing. But RDF is a very good basis for it. And actually, I think a better way of thinking of that common data model is you could think of that common data model as being a combination of RDF representations of a number of different standards that actually work together. In other words, think of it as a profile of a number of different standards, a sort of a combination of different standards that are represented in RDF and that are known to work well together. So that's another way of thinking of that common data model.
And in that way, it seems like that would be easy to develop iteratively over time.
Yeah, it has to develop iteratively over time.
Yeah, I mean,
right.
It would be useful far far sooner than it would be complete.
Yep, that's right. Yeah, so portions of it could be more stable than other portions and could be more usable than other portions. That's right. But as I mentioned, that it will always be a moving target.
The next question is a tools question. Are there BI reporting tools based directly on RDF OWL data format?
Yeah, that's a good question. There are some young ones, but that's a very interesting question because I personally think that there's a big potential, and if Oracle's listening here, they could cash in. I think there's a big potential for using existing BI tools that tend to be based on sort of the relational models. They tend to be accustomed to consuming relational data and marrying those with the kind of RDF graph-based models. And a way that that can be done is to expose RDF data using Sparkle queries, because a Sparkle query essentially produces a table from RDF data. So it can give you kind of a relational view from your RDF data. So I think there's a big potential for marrying those together that way. Mm-hmm. I have not seen that done yet with the big commercial BI tools.
Nor have I, actually. I think that's a really interesting thought. A two-part question. Part one, could SCOS play any role in your design? And do you want to maybe say a quick word about SCOS for the audience and what it is?
Sure. SCOS stands for Simple Knowledge. Oh, what does the O stand for? Something knowledge representations. No, I forget what the O is. Anyway, it's an ontology. It's a very simple RDF ontology for expressing relationships between concepts in. I think it was originally designed for thesauruses, or thesauri, if you prefer the Latin.
That's right,
yeah. And the nice thing about SCOS is that it's very light. It's very sort of simple to use, and has fairly minimal semantics, which is both good and bad. But I absolutely think that SCOS would play a big role, actually, in this, in allowing relationships between different standards to be expressed in a very kind of easy to capture way. Yeah, I think SCOS is quite a good candidate, but I think elements of OWL will also be used as well. And it's not a matter of choosing one or the other. They can both be used together.
Excellent. And then part two of that same question, is ICAT recommended for other sectors than medical?
I have not heard it being recommended for other sectors than medical. I mean, ICAT was a specialized version of Web Protege, which was designed for the ICD-11 effort. But Web Protege can be used for anything, for any domain. And it does have the capability that you can build specialized front ends for it, just as was done with ICAT. So I suppose there is that potential. Next question.
Next question is a comment. The real first step is to get the federal government to offer incentives for interoperabilities. I guess the question that I would have is, do you agree with that statement?
Yes, absolutely. I do agree with that. And that is happening to some extent. There are some incentives now under the so-called High-Tech Act. It might be part of the Affordable Care Act, I'm not sure. There is a notion of what they call meaningful use of electronic health records. There were various incentives for instituting electronic health records, and the meaningful use criteria specify certain hurdles that have to be reached to allow that electronic health data to be meaningfully used, not just stored in an electronic way, but also be useful in being stored in an electronic way. And so there are various thresholds that an organization needs to reach in order to be better reimbursed for Medicaid or Medicare, I forgot which. And that provides a significant financial incentive. So organizations are doing that. So that is a step in the right direction in general, and in the sense of trying to get interoperability. There are various complaints about the actual criteria that have been chosen, about how effective they are. But anyway, so there are some efforts in that direction. But yes, I absolutely agree that the federal government needs to have carrot and or stick incentives, because there is no natural business incentive for a healthcare provider to make its data interoperable with anybody else's. Next question.
Next question is, do you have any additional suggestions regarding getting the effort funded? It sounds like you've touched on that a bit, but
yeah, that's a good question. So various pieces of this, the ICD-11 effort, the ICAT effort, was a funded research project under Mark Muson's group at Stanford, for example. And there various kind of pieces are funded. There, the Standards Hub and the Translations Hub are not funded yet, and the overall program of the Yosemite Project as a roadmap is also not funded. But my hope is that by articulating this roadmap, that it will draw attention to this need, and hopefully will bring more funding to it, because it is an achievable goal. Next question.
Next question, I'm going to rephrase just a bit for you, David, because I know that the answer is there are many. So what are some of your favorite successful use cases based on this semantic interoperability technology?
Yeah, that's always a tough one.
Yeah.
There are a lot of them.
Or some that you might like to mention. The question is, what are successful use cases based on this?
Yeah, there are a lot of them in a lot of different domains, and there are a number in the biomedical domains specifically, and life sciences in general. There's pretty good uptake in pharma, the pharma industry, particularly in research. Basically, in areas where there is diverse structured data that needs to be semantically linked up. That's the kind of problem area that this kind of technology is good for. I don't have a list of success stories to point to. The W3C used to collect a few of these years ago, and so there are some listed on the W3C website. But this technology has been coming along for years, and it's been used in quite a number of places. Actually, Eric might be able to point you to some better ones.
Yeah,
or
we've talked about a lot of these as they have come up over the years at SemanticWeb.com. There certainly are many, many use cases out there. A slightly more focused question is the next.
Actually, let me just throw in one other thing. However, the reason I am interested in this problem, and the reason my focus is on this healthcare use case is because I believe that there is a huge potential here in healthcare for this technology. There's a lot of benefit that can be had through this technology, as I just described in this roadmap. Yes, Eric, next.
The next one is a much more focused version of that last question, which is, are you aware of any equivalent efforts in the Department of Defense? DoD and the intelligence community really need it.
Yes, I am definitely aware of them. I'm not involved in them, but I'm absolutely aware of them, and this technology is being used in those organizations, and for things like anti-terrorism, whatever.
My answer would have been the same, perhaps with the additional caveat that getting the three-letter agencies to talk about what they're doing is much more difficult. But I do know that they are absolutely leveraging the power of RDF and OWL. Next question, where can we find already built RDF OWL data sets for standards like ICD-9, CPT, etc.?
Yeah, a good starting point is the BioPortal website. If you just Google BioPortal, that you'll find it from NCBO. That's probably the best place to look.
Okay,
next.
Lots more questions coming in. So, is not one of the challenges faced in interoperability that software engineer training omits RDF-like representations in the software development lifecycle? That is, the design patterns adopted by HIT developers generally omit approaches such as the one proposed.
Yeah, so that sounds like it's talking about the cultural issue that there isn't yet a lot of expertise in the healthcare IT community about RDF. That is true.
I think, yeah, that's how I read it too. And follow on from it, I think the training, be it at the university level or other software training, other computer science and software training programs, that is definitely a pain point.
Yeah. However, you'll note that in this roadmap and strategy, does not require every healthcare IT person to understand and use RDF. It sort of isolates, it allows them to use what they are currently using, right? It doesn't ask people to change to be using RDF and OWL. It instead is focused on providing mappings from what they are currently using into RDF and OWL, so that those kinds of transformations and interoperability can occur. Now, obviously, the ones that are implementing those tools that are going to do those translations will have to understand RDF and OWL, but it's not everybody. Most of the people in healthcare IT don't have to really be aware of it.
All right, next question. You mentioned that existing standards are changing at a rate of 3 to 8% a year. Would source version and target version be included in the translation metadata? And do you anticipate the translation rules being able to keep up with the source and target changes?
Yes, absolutely. The versions do need to be in there because they will affect the translations. And yes, the translation rules have to be updated for them. Again, translation is not something that we really want to do. It's something we do of necessity. And when you need to translate data from one to another, there is just no way around it. You got to do it. So, yeah. Next question.
Next question is, can RIM be considered as a basis for the common data model?
So RIM could be a basis for a common data model, but it's very, very hard to have a crystal ball and say and be able to guess what is really the best common data model that should be selected. The RIM stands for Reference Implementation Model, I think it stands for, something like that. It's a data model that was put out by the HL7 organization that that tries to unify the various data models or provide a common basis for the various data models that are used in HL7. And so in theory, yes, it could be. In practice, would it be the one that people would converge upon and like? I'm not sure that it would, but the part of the point of this strategy is to be agnostic about that, to let that be decided by the community and by the standards work, and for this strategy to not be dependent on that. Okay, so whatever common data model emerges, it can be used in this strategy. Next question.
We have many more wonderful questions. Unfortunately, we are out of time. Thank you, David Booth, for this fantastic presentation and very lively Q&A. Thank you to our audience for all of these great questions. I'm afraid that is all the time we have. Just to remind everyone, we will be posting this recorded webinar and the slides to SemanticWeb.com within 2 business days. That's by end of day next Tuesday. And I will send out a follow-up email to all of the registrants to let you know where to find those files when they are posted, as well as any other related information. Thank you to all of you for attending today's webinar. And thanks so much again to David Booth for steering the ship today.
Thank you very much, and thanks to everybody who attended.
Thank you all. Have a great day.